So to find a horizontal or oblique asymptote, there's actually a little bit of math involved, and once we get there, I'm hoping once you see the strategy I'll show you here at the end, you just by looking at these, you're going to be able to tell, this has a horizontal asymptote and here's where it's at. This doesn't have a horizontal asymptote and here's what I got to do to find the oblique. So there's some algebra involved, but let's go ahead and just let's use our technology to kind of look at something. So round one, it turns out that all three of these actually have the same horizontal asymptote. So let's go ahead and find out and figure out what it is. So 3 over x squared plus 4x plus 4, when I graph this, right, here's what the graph looks like. Again, because I think the negative 2 is where the 0 is down below, the behavior of the vertical asymptote is the same in both directions, but we can kind of visually see that as we approach positive infinity, the graph is getting closer and closer to the x-axis. And as we approach negative infinity, it's also approaching the x-axis on that side. So the horizontal asymptote for this graph is y equals 0. Okay, and because I told you guys that these all have the same thing, right, you can expect the same thing for the next two graphs, but let's just go ahead and see that. So when I turn that guy on, again, here's the graph of x minus 3 all over x squared minus 2x minus 8, and we can see that, again, we're talking n behavior, and I'm actually crossing it this time, but as x gets big positively, the graph is getting closer and closer to the x-axis. As x gets big negatively, the graph is getting closer and closer to the x-axis. And then we actually do cross the x-axis at one time. But this also has a horizontal asymptote of y equals to 0. And then last but not least, this is one that we found a hole in. But here, since we're talking about end behavior, again, notice the end behavior, as we approach positive infinity, the graph is getting closer and closer to the x-axis. As we approach negative infinity, the graph is getting closer and closer to the x-axis. So this also has a horizontal asymptote, and y is equal to 0. All right, now there's a reason why that's occurring. All right, we'll investigate that in a strategy that we'll talk about soon. But for sure, we know in that first round, all right, what we have is we've got a situation where there is a horizontal asymptote, and it happens to be the x-axis, right? Y equals 0. Alrighty, so that's that first round. Second round, all right. So in the second round, all right, let's again turn to technology. This first one, x minus 3. Oops, let me turn that guy off. Turn that one on. Right. So we're talking about x minus 3 over 2x plus 4. We do see that there seems to be some horizontal line where the graph, as it's not the x-axis, because this is above and that's slightly below, or excuse me, this is a little bit above and this is a little bit above the x-axis in both directions. So it's kind of hard to check it out, but perhaps if we maybe zoom out a little bit, right, we can see, right, that this asymptote, this horizontal one, is just slightly above the x-axis. So it's not the x-axis, it's some other y equals. So we do see there's a horizontal asymptote, but it's kind of hard to see algebraically, or excuse me, graphically. But let me zoom in a little bit, right? And I think right there, right, there's 1. And if we keep coming out this direction, right, remember, let me just make sure we got here, right? This line, this right here is 1. But if we keep going out, right, here's 1. And if we keep going out and keep going out and keep going out, right, here's 1, right? What we seem to be is somewhere between 0 and 1, right? And it even gets closer and closer and closer. Let's see in the other direction. So there's something between 0 and 1, all right? And so again, in this direction, there's 1. And in this direction, we keep getting closer and closer and closer to some value between 0 and 1. What that value is kind of hard to see on a graph, which is why we're going to learn some algebra. But what I will tell you is that it is y equals 1/2. All right, so we know it's existing. You're going to have to trust me that's a half. I'll algebraically show you and prove it to you in just a moment. But we do see that we do have a vertical asymptote, but it is not the x-axis. It's something sitting a little bit above it. Okay, what about the next one? Let me turn that on. And when I turn that function on, again, we can see that this clearly, right, there's a horizontal line above the x-axis. So we can visually see that there is a horizontal asymptote. What is that y value that it's equal to? Well, let's zoom in a little bit and see if we can't find this one. So there's 2, right? And if we go in this direction, notice that the graph, as we get big positively, that graph seems to be getting closer and closer to 2. And on this direction, right, let's go the negative direction, that graph, again, there's 2, right? That graph seems to be getting closer and closer and closer and closer to 2. So for this function, let me move back over to the... So for this function, it looks like, again, I keep losing the 2, but it looks like the horizontal line that's serving as the horizontal asymptote is y equals 2. All right, so we observe it, and we can see it, and we can find it. For this next one, let me turn that off and turn this on. Well, again, we notice that there does seem to be a line, a horizontal line, where the graph, as x gets big in this direction, it approaches it, and as x gets big in this direction, it approaches it. So let's zoom in a little bit, and that line appears to be 1, right? Because if I go out in this direction, notice that the graph is getting closer and closer to 1, and if I go out in this direction, notice that the graph is getting closer and closer to 1. We don't actually cross it this time, but it is 1. We're talking the end behavior. So let me zoom out, zoom out. So it looks like, right, y equals to 1 is the horizontal asymptote. So this has an HA and y equals 1. All right, so we have 2 cases where there is a horizontal asymptote in these 2 cases, but it's extremely different. Right here we got y equals to 0, and here we've got y equals some other values, and in this case a half, 2, and 1 respectively. All right, why that's the case? Coming soon. What about round 3? What do these graphs have? So again, let's just go to the technology and kind of take a look. And so when we graph x squared minus 4, right, we notice that this graph, right, doesn't seem to have a horizontal asymptote. This one's kind of harder to see, but I wish I had a straight edge on me. But if we basically put some asymptote right there, right, imagine the edge of this piece of paper, right, the graph seems to be following it in this direction and seems to be following it in that direction. So as x gets big in this direction, we seem to be this line, and if we go to negative infinity in this direction, we get closer and closer to this line. So this guy has what we call a slant. I would call it a slant asymptote, but technically speaking, it's oblique, right? But we can see it's a slant. It's some line y equals mx plus b, and believe it or not, we'll find it in a moment. We can kind of see it. So what about the next one? X squared minus 6x plus 5 over x minus 2. Well, when I graph that, come on, turn on for me. I'm going to have to figure this out on my phone. It sometimes turns on and sometimes doesn't. There we go. All right, so this one, again, if I kind of zoom in a little bit, we have the same behavior. So it looks like, again, let me borrow my kind of straight edge there. As x gets big positively, we seem to be along this line. As x gets big negatively, we seem to be along that line right there. So there seems to be a line that the function eventually behaves towards. All right, so again, we have a slant asymptote here, or technically oblique, right? And so it's some line y equals mx plus b. And then last but not least, x cubed minus 8 over x squared plus 1. When I go graph that one, right, this one's really wild, all right? But when we kind of look at that, right, we can visually see that there seems to be some line, right? And again, let me use my paper as a straight edge. As x gets big, right, the graph starts to hug that line. As x gets big negatively, it seems to correspond to that same line in both directions. So again, we can visually see with our calculators that this also has some slant asymptote, right? Some people would call it oblique, and it's some line y equals mx plus b. All right, so there's your possibility. So there's 3 things that can happen. We have a horizontal asymptote, it's the x-axis, y equals to 0. We have a horizontal asymptote, but it's truly equal to some y equals L, right? Half, 2, 1, -3, -4, whatever. Or round 3, we have an oblique asymptote. And in the cases that I'm showing you, they were all slant asymptotes. There was some line that we have. And now what we have to do is figure out, how do we find all this stuff? Without technology, because I was very heavily on technology, is there a way to figure this all out without using technology? And once you see it, you'll notice that, I mean, this almost sort of throws us out the door, because it's really, really fast once you see what you're looking for. But I'm going to do that in the video that's coming soon, because we're already 10 minutes into this. See you guys in a moment.